Hello there. My name is Alan, and this video is currently being created when this tutorial series, is on, I think, number 103 or something like that. You'll notice that the format has changed. There's not much to see. And the reason I'm making this video at this point is sort of by request. That the video that had previously been in this slot had been described as not explaining enough about how to set up the environment for what's going to follow. And I had a look at that video, and what I realized watching it is that in fact it would give that video would give that impression because it explained a lot of things that seem to have something to do with the intended environment, but in fact actually don't. So I could entitle this video "Setting Up the Environment," but I'm not going to, because there is no environment to set up. Okay. Now I'm going to change something. Actually, well, I won't change it yet. I made a modification to one of my system settings, and I want to change that back. As you can see, I'm using the Windows command prompt, which is something that you will have to learn all on your own. I'm using a program called Edit, which if you have never heard of, you will have to learn about all on your own. I'm editing a batch file, which, if you don't know about batch files, is something you'll have to learn about all on your own. Now you can see, now all you're seeing is a blank screen, and so I'll pause this. Okay, I fixed it up. What I had done was I changed one of the settings in my system that makes the batch scripts quieter, I guess would be the right word. They don't print out what they're doing as they're doing it, and I thought that was that was great and everything, but in fact it's not so great because there's no way to turn it back on again. So when you really do need to see what it's doing, you can't. So no, I'm not using that setting. But that has nothing to do with our environment. Now, you are currently being restricted, your view, that is, to this small box, and that's going to be the format of the following videos. It is not, on my machine, it's as small as it normally is. So you have the advantage of actually being able to see these things at this normal resolution that they would be under DOS or even Windows XP. But I'm running Windows 7, and I cannot make this box any bigger than it comes. If I press the maximize Alt-Enter sequence, I get this error. System does not support full screen mode. No. Yeah, that's a lie. They could easily make it full screen if they wanted to. It doesn't have to be full screen in the sense of changing the video mode. You could fill up the entire screen. If you press the maximize button in YouTube, right, you're seeing a full screen. If YouTube can do it, and then the operating system can do it. So it's just a silly. It's a removal of a useful feature for no reason whatsoever. It's difficult for me to read these little letters. I'd rather have it nice and big as you're seeing it. Now, when you run the command prompt, which again, I'm not going to explain anything about it, I refuse to. But I'm going to show you what I started another one, okay? When you run it, it's going to look like this. Okay? Well, except it'll have your name here rather than mine. Right? So, now I'm going to give you the entire entire sequence of operations necessary to set up our so-called environment. Step 1. If you have on your system more than one hard drive, then select one of your drives that is not where your system is installed, and for me that happens to be D, and go to that drive. Okay. Press and leave the caps lock key on for the duration of anything that you do in these boxes. Make the following directory. Well, it already exists. Okay, but if you did that, you wouldn't get an error. Change to that directory. Okay, and now the environment is set up, and that's all there is to it. The only problem is the next time you run the command prompt, I'll run it again just in the normal way, you'll end up back here again. And so you're going to have to change drives and change back to that directory. And I leave it to you to figure out how to make perhaps a shortcut that would start the command prompt program and start you out immediately in this directory. Okay? Now the environment is set up. Now, nothing needs to be installed. No files need to be created. No environment variables need to be set up. And so there's nothing left to do except keep the following in mind. We're dealing with a situation wherein the one program that we're going to be running almost in every session, and almost exclusively during those times, is a 16-bit program that expects to be finding itself in the year 1980 something. Okay. In those days, a path name or a file name, okay, could have eight letters for the name, and 3 letters for the extension. Okay, now name and extension is like this. A file.text. The name here is a file. That's the name, a file, and that's the extension. And the letters were always in capitals. Now, I don't know if this is going to happen, but let me just see. It may or may not happen. I'm going to make a directory. Oops. Well, actually, I want the caps lock called funny, like this. Okay, now I'm going to run the debug program. Now I'm using small letters on purpose. Now I want to see if it has any effect on the... No, okay, it remains... this part remained the same. Now, it turns out that sometimes when we run this debug program, we will want to provide a file name parameter to it. Okay. Now, if that file name parameter is not in the 8.3 format, then it's going to fail. So I'm going to make a file using the edit program, and I'm going to, well, actually edit is 16-bit. I'm going to use Notepad. A file with long name.text. Okay? So there it is. Now, if I try to use this file with the debug program, it's going to fail. Now, how I did that is magic that we can easily figure out. It says file not found. Okay. Now, that's because it expects it in the 8.3 format. Now, it's possible for me to supply an 8.3 version of this name to the program, and that involves a lot of trickery, but it is possible. For instance, let's see now, how do I do that? Let me think for a minute. Okay, now if I use the directory command with this -n here, it tells me what the 8.3 version, how to specify this file name in 8.3 format. So if I said debug, go back to capital letters, it accepted it, see? And it has what you didn't see me do it, but I typed these letters in there. Okay? Now, the file is still as it was. But suppose I used the debug program to modify that file. Now, I'm not explaining to you how to use the debug program to do that. I will just do it, okay? And I can do it by just pressing a single letter. So I'm going to recall this command, and then I'm just going to type the letter W, and it should write it back out. Okay, it wrote out 8 bytes. Q means quit. Okay, well, it didn't change the name. Maybe because it didn't add anything to it. Let's try that once more. Add an extra byte. No, it didn't change. Okay, so That's fine, but there's no point in having to go through all that trouble. So if we stick to 8.3, then we won't have that problem. Oh. Okay, yeah, that's it for setting up the environment. The rest of the tutorial involves a different environment. If you think of the command prompt program as a type of environment, then the debug program, in exactly the same way, is another environment. This environment provides a prompt with some letters, and then there's a blinking cursor. This environment provides just a dash and a blinking cursor. Okay? But in terms of the idea, this is another environment that is outside of this environment. But we have to be in the first to get to the second. Now that we're in here, none of the commands that we could have used before are valid. We're in a totally different environment. And it takes too long to go through all of the commands, but the list is fairly short. To see the list, you type question mark, and that is the complete list of commands that are available in this new environment. Okay? Now we're not going to use any of these ones down here, but we will be using this, not that, this, no, this, no, this, and this. Okay, so about half of them. We'll be using about half of them. All of these commands are single letter commands, okay? And they don't need to be followed by a space. So for instance, this first command, which means assemble, takes as an argument, optional argument, something called an address, a memory address. Now, I could provide a space. The numbers that we're dealing with are always in hexadecimal, and they're always going to be between 0 and 4 Fs. Okay? So the number that I can specify here is up to a 4-digit hexadecimal number. So, for instance, I can say A space 2BC. Okay? Now, if I press Enter, I get back to my other prompt. But I could also say A2BC, and it does the same thing. Spaces are not required for the first part. Some of the commands take more than one argument. Let me just print them out again. For instance, this fill command takes 2 arguments, and they don't explain it to you, and I'm not sure how to get any further help on it. I figured it out just by experimenting. Range here is actually 2 numbers, okay? It's a start number and a finish number. List I'm not sure about, but I know that a single number works. So imagine like mem set. Okay, this is like mem set. And the range is a memory range, okay, in our range which is between 0 and FFFF. So fill, for the first number I shouldn't have to specify any space, but let's suppose I say 400, okay, now that's the beginning of the range, or let's make it something weird, 403 space, that's the start of the range. Now the ending number has to be bigger than the starting number, so let's suppose I say 4, 2, B, okay, so I have some hex in it. Next is what they've called list. Now, I only know, and I'm not going to try the experiment now, but I imagine that I can specify a list of values that would repeatedly be set throughout that range from 403 to 42B. But I won't do that yet. In fact, I never use it. You could try it on your own. That's how I learned all this, by the way. And I want to mention that again after running this experiment. Okay, now if it's like memset, okay, you know memset. If you know C, you know memset. So it takes a pointer, right? A value, a character value, and a number, a count, right? But there's no count here. The count has been specified already. So now we're just going to specify the character value. Now I'm going to specify the value, some hex value, which means 2 digits only. And I'm going to say 7C. Okay, let's made that up. Or actually, let me try B. No, we got B's. C is okay. Now, okay, doesn't provide any feedback. If I want to see that something actually happened, I have to look at these addresses, right? Remember, the range is from 0 to FFFF. If I want to see memory within this range, I use the dump command, okay, which optionally has a range. So let's try this range. D 403 42B. Okay, so you can see that everything's exactly the same. Now the question is, maybe it was already, we can't see. We can't see beyond these. Maybe it was already equal to that value. I find it pretty unlikely, but who knows? So I could change that to, let's say, 400 to 430. D 400 space 4. Actually, I don't want to go. If this is an inclusive dump, right? So if I go 430 here, then it's going to do this block all the way to the end here plus one more. I don't want that. I only want to go to the last the last element on this line, which, if you know hexadecimal, and I'm expecting you do, then you know that 2F is here. It's like 29. F is like 9. So I've gone from 400 to 429, right? Hex 9. And it turns out that these had the value of 0. Now, that said that the dump command takes an optional range. What if I don't provide a range? You're going to find that pressing D again simply continues where it left off. So the next time I press D, this next line should start at 430. You can always, you shall, I'm telling you, to completely ignore these preceding 4 digits with the colon. That is something that you'll just block it out of your mind. I'm going to press D again with no parameters, and as you can see, it continued on from where we left off. If I had done it the other way, 400 to 430, which as I told you is going to give us one extra one. There's the extra one. Now if I press D again, it's not going to start at 430. It's going to start where we left off. It starts here. Okay? So it's just a continuous, it's a thing that just continues going where we left off, so we don't have to keep typing in the number. Now, how much time have I spent? Well, it's not too bad. I'm going to continue talking about this stuff for another 15 or 20 minutes, okay? So if you can press pause if it's been too much so far, or if you want to try some of these things. Okay. Now, as I said, I wanted to make sure that you understood. When I started out making these tutorials, okay, I was just simply using what I had recalled from over 20 years ago when I used this program before, what I could remember about how to use it, okay? So that means that as I'm going along, as I went along, I learned how to use this program. Right? And now I know a lot more about it. So I'm at the end of the process of learning how to use it. Okay? And so none of the explanations I'm giving to you now are actually necessary. Because if I could learn it, you can learn it. Right? And I didn't learn it mainly by looking it up. In fact, I didn't look up anything because this is such a small set of things that you can do, right? The program in itself is not that hard to learn how to use. If you've never used a debugger, right, then you can stop now and go to figuring out how to use a debugger, because this is a debugger, and I'm expecting that you understand the concept of a debugger and what that means, what it means to debug something, right? You might know C, and you may have written programs and simply ran the programs, but maybe you've never debugged them. And if that's true, then you don't have enough information. You don't have enough background to continue. Okay, now if you have run a debugger, you know you are aware of the two types of things that you do, right? Well, the view inside of a debugger is a list, in C for instance, is a list of instructions, okay, or function commands, or A plus B and so on, everything followed by a semicolon, right? And of course there's if and if else and all that sort of stuff. But in particular, As you're debugging your program, now some people actually use the mouse for this, but I never did. Usually there are two keys, okay? And I think the typical one, most debuggers, the default F7 or something means step. Go execute the next line, right? And mine's not set to F7 in my C debugger. Whatever that key is, there's that one, okay, and that's called step over, okay. Maybe it's not F7. Anyway, it doesn't matter what it is. And then there's another one called step into. And if it's a graphical interface, usually the step into is represented by some curly brackets and a hooked arrow. Okay, and what that means is if it's a function, right, and you go and you press step into, then it's going to, the next line is going to put you inside the function call. Okay, is it okay for me to quit this and go into edit for a minute? I'll get rid of the caps lock. Now this is C. Okay. If you have a main, whatever. I happen to do my braces like in this format. Most people don't like it, but I like it. If you're going along, maybe you have a variable v, and you want to call a function. Okay, and then so you might say v equals foo, right? And then we're going to make another function. I don't know, foo1. What do they always do? Bar, foo bar. I don't know why this is. It's a kind of a Linux thing or something. Okay, let's suppose this one takes an int. And let's say it uses some conditional. I don't know, percent 7, 8. There's some tests, you know. Just trying to make something happen. Okay, if whoever foo of our return percent divided by, well, let's make it not 8, let's make it something prime or something. This will have to be set. Otherwise, return plus 6. Okay, complicated enough? No. Okay, Now I want to say on my next line, v plus equals bar of foo. No, make it easy. Bar of v, right? Okay, now when I press the step over key, if the debugger is currently on this line, and I press the step over, then the debugger is going to be on this line, right? And v is going to be equal to 6, right? So that's a step over. So here I've done step over. Okay. Now I don't know how to represent step into, but now if I do step into at this line, I'll represent that with a different way. How about wiggle? Okay. If I press step into, I'm going to be here. Right? Doesn't look very good, does it? How come? Oh, just one little. So here's step into. Okay, so I got step over here, and now I'm going to do a step into. This thing is pointing here, and step over brought me immediately to this line, and V was 6. Now, if I press the step into key, then that's going to bring me to here. If I step over, I would be on this line, which is missing. It should always be a return. If I step over, I wind up here on V. If I step into, I'm going to go into here. Okay? Now, as far as the debug program goes, T is step into. Okay? Step into. I never use the parameters, so we're never going to use that. T on its own is the same as step into. P on its own is step over. Alright? It's simple enough. If you know that, then you know that. And similarly in C, if I don't want to step over or step into, I just want to let the thing go with no stopping, then that's this value, G. Okay? Step into, step over, run. Okay? That's that. Now what about in my C example I had foo and bar and all those things, and sometimes well, I didn't have any arithmetic operations, A plus B, so do that. What about the instructions? In C, there are lines like you saw, V equals foo. Okay, this is one. We consider this here to be one line. Okay, I don't know what the word is. There's a technical term for it when you finally run into the semicolon. I think it's called synchronization, sequence point or something. If we think of the program in terms of lines, 0, 1, 2, 3, and so on, right? This is one line, and step over takes me to here, right? So this is like, in a sense, you could say, a single unit of operation of the program before it proceeds to the next thing it's going to do. If there's stuff happening in between, this is still the same. It's still one. This is still line 0, right? And that's all because of this semicolon. If there was a semicolon here, and I did this, now this here is 0, 1. Now this has become 2 lines. The semicolon delimits lines, okay, of operation. Now the same thing is true in our debug environment. But the instructions are not C instructions, they are machine instructions. One line may be a function call, may include a function call, right? And there are no semicolons. To see the instructions, there are two ways. To see the current instruction, that is, if it was a regular debugger, where that little arrow was pointing, you can see that by pressing the letter R, and you see a lot more. You see what line we're on. We're on line 100. Remember, forget these. We're on line 100. Here's the code, right? Foo, or whatever, or 3 plus 7, or whatever it is. Okay? And this here is stuff that I'm going to explain as I go along. These are called registers, and they have meanings and things. To see more than one line at a time, there is look at the help, and there's an instruction called U, unassemble, which takes an optional range. Okay? Now this range option, it works in exactly the same way as it did with the D and the F. Alright? So let me press R again to show where we are. If I press U without any parameters, it's going to show me as many lines as it can. I think maybe up to 10 or something. We'll count them. Of code, okay? Now, how many did I get there? All the way up from 100 to 1D. Now this number, right, is not the line number. That's the thing that you might find confusing, okay? Because you'll notice, for instance, this is 101, but this is 104. So from one line to the next line, the number jumped up by 3. And the reason is because this here represents our position, and our position depends on the amount of bytes it takes in order to specify the instruction, right? In the C world, that's the line 0, line 1, etc. is a fiction, right? So one line to the next could contain thousands of instructions, right, that you just don't see. Well, here you see everything. And we can see that this particular instruction is only 1 byte long. Okay, this is called its opcode, an instruction. These are called instructions, and these are called opcodes. This is the binary code that is the equivalent of this kind of semi-English version. This is called assembler. Okay, the reminders for what these things do. Okay, this is the actual machine code instruction called the opcode, and this is the opcode for this instruction. This is an invention of someone's imagination, right? The CPU certainly doesn't know what the letters POP and all that stand for. It only knows zeros and ones, so that's what you got to give the machine. Here's another instruction which is written out in such a way that it helps us to understand what it's doing. It looks like something is moving from somewhere to somewhere else, okay? And in fact that's true in this case. In this case, after this completes, that is, once we get to line 104, the number 0001 will have moved into what is labeled BX. So this will have a 1 here if we trace through it, okay? Using our trace. I could do it. We're currently pointing at 100. That tells us, by the way, where we're pointing. If I trace, now I've gone to line 101, right? And here we are, where it says that it's going to move 1 into BX. And if I press trace again, you can see that BX has become the number 1. Okay, now these instructions, right, you don't need to remember the opcodes, but these instructions I was able to recall, some of them anyway, as I went along. Sometimes I couldn't recall them, and I tried experiments, I tried guessing, and I could find some, and sometimes I failed. And eventually I downloaded a document that contained all of them, and so I could at least look them up and try to find the one I wanted. This one, though they're not that hard, if you just press U, and look at them, you can sort of guess what they're up to. CMP, compare, okay? Increment. JNZ, what could that possibly mean? Well, I'll just tell you, but it means jump if not 0. Okay? So after a while, you sort of get you get the code, right? This means add. This one means shift left. Shift left. Okay? Now, a shift, in terms of binary numbers, is a shift of the bits in one direction or another. Okay? Well, I can tell you that nothing's going to happen due to this instruction, because the way this works is it's going to shift all of the bits in BX, and it contains 1, an amount CL. That means C low, okay, which means the lower byte of the CX part. And there's nothing in here anyway, so it's not going to shift anything, and nothing is going to happen. Okay, and that's a start, right? Now you run the debug program, and now you just I'm telling you, open it up, run it, press U, have a look through the instructions, and start trying things. Just, press A for a symbol, and start trying some of the instructions and see what happens. That's what I did, and I learned a lot of things. I learned out how most of these instructions work. Alright. You can also guess, for instance, if there's a shift right instruction, and there are also ones that do like rotate and all sorts of things. Anyway, So, like I said, there's no environment. The environment is what I did, is debug. We learn how to use the program in the following videos. It's not taken as a given that you or I understand and know everything about it. I didn't. I know more now. And you'll see me struggle through in the next video, for instance, trying to recall how to divide one number by another number without looking at the manual. And eventually I figured it out. In fact, I didn't figure it out during the recording of the video. I had figured it out, and it took me a few hours to figure it out just by experiment. I knew that it was div something, right? And so I put different values in here. I figured out how to put values in here, right? And then I tried div, and I tried various values. And one way to get hints is to just keep typing view, right, and have a look through and see how this is how the debug program is interpreting these instructions. This is random garbage, but they still correspond with instructions. And you might randomly run into something and figure out, oh, this looks like this is how you decrement something, right? And look, maybe this means jump. In fact, it does. And just by looking through the random garbage, it gives you hints. Okay, there must be something that does exclusive OR, right? There must be something that does OR. And it's probably OR. Here's addition, here's subtraction. Okay, look, there's something called call. There's a way to call, or to go to another location, like function call. Maybe there's a return, and that makes you think, let me just try and see if there's something called return. And then you think, oh, well, it's always 3 letters. Well, it turns out there is, right? And it's very easy to figure out if you only just start doing it, you're trying it yourself, right? You're not going to figure it out by watching me do it. And nobody ever does. Nobody ever figures things out by watching other people do things, right? And it's no fun to watch somebody else do something anyway. It's more fun to figure it out yourself. And I'm leaving it to you to figure these things out. Right? Have fun with it. Play around with it. It's a toy. You paid for it. It's your toy. Play with it. Okay. So this will now be the new number 3. Okay, see you.